Hello, I'm Chance Dunlap. I'm the Business Unit Manager of the Zilker Labs digital power products at Intersil. And today I'd like to showcase the new ZL8800. This device is a dual phase or a dual output PWM controller. So we're just showing one output with it right now, the ZL800 device with an external ZL1505 gate driver, and of course is a synchronous buck controller. One of the main benefits of the product is the ability to have a PM bus interface, which is essentially a two-wire SM bus or I2C interface, such that you can configure the device and then you also have telemetry. Now the benefit of telemetry is you're able to monitor all the different aspects of the power supply real time. So at any point you can know what the input voltage is, the input current, the output voltage, and also the associated output current of the load. This gives you the ability to continuously monitor your supply in the application and respond to faults and events that occur. So I'd like to show you on the bench how this device works with this GUI such that we can look at how it monitors all the data real time. To really understand the benefit and the power of the ZL8800 and what digital power can do, let's take a look at it in the actual lab environment. So what I have here is the evaluation board of the ZL8800. This is the dual phase board. So we have a single ZL8800 IC on this board, and we have the two separate channels. Now these are tied together to a single output voltage, so it operates as a dual phase converter. The power stages that are shown here are using just Dr. Moss devices, and you can see the output inductor and the output capacitors. Now in this setup, I'm running from a 12 volt VN source. So you can see the multimeter is running right now at 12 volts in. I've got a 1.2 volt output, and I've got connected to a load box. So we can start manipulating different conditions such as input voltage and the output load. The last piece I have on this board is, you'll notice this dongle. This connects into the PC that's running the new Power Navigator GUI. So the PC will send signals across through USB that's converted into I2C or the PM bus commands to talk to the device, and this provides all the real-time data back, such as the input voltage and the output voltage. So if we take a look at the GUI, we can see exactly the real-time measurements. The GUI is monitoring the 5 key parameters we were looking for on the board: the output voltage, the output current, the input voltage, and the input current, along with the temperature of the IC. So as we look on the GUI, you can see each one of these presented clearly on the main page. The output voltage reading 1.2 volts. You can see the output current right now with a no-load condition, the input voltage, input current, and also the temperature. You'll notice the temperature is reading two different things. It shows an internal temperature and an external temperature. The difference between them is the internal temperature is the actual temperature of the silicon, the ZL8800. The external temperature is measured at the inductor. So we're using the external temperature sensor, the 3904 NPN, just to measure right up against the inductor, so we can temperature compensate it, and that way we always have an accurate output current measurement across temperature. To show how this can change, we have a can of freeze spray here, and if we just simply freeze the device, you'll notice how right away within the GUI, you can see the internal temperature dropping by several degrees C. One of the other parameters that's constantly monitored is the input voltage. So we can just vary the input supply and watch how the GUI continuously updates and monitors it. So I'm taking down from 12 volts, down 9 volts, 8 volts, and we can watch how the GUI will continuously record the voltage seen at the IC. If I come back up to 12 volts now, same thing. Another parameter we can vary would be the load. So we have a load box connected. We just turn it up from 0 current up. Right now is at 0.3, and we continue increasing it. And you're going to see that the GUI will continuously monitor the load current seen on the board. So right now the load box is reading a little bit low because of the voltage drop across the cabling, but still you get an accurate measurement of what's occurring exactly at the point of load converter. So that demonstrates the capability and the simplicity of using the new Power Navigator GUI on the ZL8800. For more information on configuring the device, please watch the remaining videos.